Hello, I'm Emily Lee, and today I will be discussing analysis of seized drugs by direct ionization, ASAP-MS. For today's presentation, I will be covering the radiant ASAP and how it can be used as a rapid screen for seized materials. I will start with how the radiant ASAP works and the ionization used, then move on to seized drug analysis, including sample preparation and analytical methodology. Let's start with analysis with the radiant ASAP. Radiant ASAP stands for Rapid Direct Analysis Atmospheric Pressure Solids Analysis Probe. The small footprint instrument combines the simplicity of ASAP with the specificity of mass spectrometry, which has already demonstrated great promise as a screening tool for seized drugs. The Radiant ASAP is designed for rapid, easy, and low cost per sample preparation with no chromatographic separation. Now we will look at the ASAP ionization process. The sample itself is introduced into the source on a disposable glass capillary. There is a stream of heated nitrogen which serves two purposes. Firstly, it provides a heat source to the glass capillary to volatilize the sample and create gaseous molecules. And secondly, it creates a nitrogen plasma in the region around the corona discharge pin, which is the basis of one of the predominant mechanisms of ionization. The nitrogen plasma indirectly creates ions from the volatilized molecules, which are then guided into the instrument and sourced on the basis of different mass-to-charge ratio before being detected and generated the mass spectrum. We will now move on to the mechanism of ionization in positive ion mode, which is typically used for seized drug analysis. The main ionization mechanisms for ASAP are really identical to those seen with APCI. The first of the mechanisms is a charge transfer mechanism, which is initiated by the corona discharge ionization of the nitrogen in the ionization source. This generates radical cations of nitrogen, which can then undergo charge transfer with analyte molecules to generate the radical cation. This form of ionization is particularly useful for the analysis of nonpolar compounds and typically is more prevalent in source conditions without the presence of protic solvents such as water or methanol. The second mechanism for ionization is by proton transfer. Now this requires the presence of water or other solvents such as methanol, which can act as a source of protons to form the ionized solvent clusters as shown. The ionization of the analyte then occurs by proton transfer, which is the main ionization pathway associated with APCI and LCMS. For the analysis of the samples, a dipping technique is used, where for each sample a new glass capillary is selected and cleaned using the Radiant inbuilt automated bake-out function. The cleaned capillary is then held just below the surface of the liquid, approximately 1 centimeter for 5 seconds. After this, the capillary is then placed into the ASAP source, which automatically triggers data acquisition. Data is acquired in positive ionization mode. Mass detection is performed using full scan MS over the range mass to charge 50 to 600. To further enhance the specificity, the data is acquired simultaneously over 4 differing cone voltages. This results in fragmentation and generation of both the precursor and product ions for the compounds. Acquisition of the 4 cone voltages generates a spectral fingerprint, as you can see from the example on this slide of ketamine certified reference material analyzed on the Radiant ASAP. Identification of a compound is based on the identification of a precursor ion. The lowest cone voltage, in this analysis 15, typically contains the ionized precursor molecule. In this example, ASAP ionization has resulted in the generation of the protonated species at 238, which is ketamine. As you can also see on this example, by ramping up the cone voltage, there are also product ions which are generated throughout. LiveID library matching software is used to process Radiant ASAP results. This can be done in real time where the data is processed live whilst the acquisition is running, or the data files can be processed post-acquisition. The software is very simple and easy to use, therefore not requiring expertise to interpret the results. The software calculates an average match score of the data against the seized drugs reference library using a reverse fit model, with a greater weighting being placed on the precursor ion. A match score of 850 is used as a threshold to indicate a positive identification. The maximum match score possible is 1000. The current seized drug reference library contains 78 compounds. This includes common drugs of abuse and cutting agents. Recently, the library has been updated to include synthetic cannabinoids, synthetic opioids, particularly nitazenes, and xylazine, following the emergence of this compound as an adulterant. Users can also add to their reference library or create custom libraries. There is a white paper available which describes this process, and this can be found linked later in the presentation. An example of the live ID results for a sample of ketamine CRM, which was analysed using the Radiant ASAP, is shown here on this slide. The sample was analysed in triplicate, as you can see from the 3 responses in the top left panel. In the panel on the right, the spectral data is shown. The acquired sample, shown here in yellow, is matched against that of the reference spectra in the library, shown here in blue. The individual match scores are calculated for the individual spectra at each cone voltage, then the weighted average is calculated to give the final match score. In this example, that is 997 for ketamine. As the maximum match score is 1000, this is a very good identification. I will now move on to seized drug analysis with the Radiant ASAP. Due to the extensive number of samples seized and submitted for analysis, a huge burden is being placed on drug control laboratories. Industry guidelines stipulate that 2 independent analytical techniques should be used to analyze a drug sample. The traditional workflow usually comprises of a presumptive screen such as TLC or colorimetric tests, followed by a more selective method such as GCMS or LCMS. TLC analysis can be time-consuming, whilst colorimetric tests are not available for all compounds and can result in a high rate of false positives. This can lead to more samples requiring further analysis, which can lead to sample bottlenecks and backlogs. Drug control and forensic chemistry laboratories require screening techniques which are easy to use, robust, fast, efficient, and reliable. The ability to update screening methods quickly is also of benefit due to the constant emergence of new drug substances. A simple and fast sample preparation procedure is also required. Radiant ASAP provides quick screening which takes less than 2 minutes for each sample, utilizes the specificity of mass spectrometry, and uses a reference library which can be quickly updated with new compounds. 229 unknown samples that had been confiscated at various music events and nighttime venues by police were analysed. Pills, powder, and capsule content were dissolved in 5 ml of 50-50 methanol water and then sonicated. Prior to analysis on the Radiant, these solutions were then further diluted 1 in 20 using 100% methanol. For each sample, a new glass capillary was selected and cleaned, and then placed just below the surface of the liquid sample, approximately 1 centimeter for 5 seconds. After this, the capillary was then placed into the ASAP source. On this slide is an example of one of the seized samples analysed. This sample was analysed in triplicate, as you can see from the 3 responses in the top left. The acquired spectra compared to the reference library is in the panel on the right. The calculated match score for this sample was 983 for MDMA. As the maximum match score is 1000, this is a good identification. As you can see, there is also a match score of 930 for MDA. This is commonly seen with MDMA as the fragmentation is very similar. However, visual review of the data shows that the precursor ion is not present. As this would be a screening method, a more specific method would be subsequently used. Here we have the results of the 229 seized samples analysed. All samples had a match score greater than 850 for one or more components within the library. There were 252 positive identifications made within the sample set. These involved only 7 substances. This may be due to where the substances were seized, as they were all seized from nighttime venues or music events. MDMA was the predominant compound detected, as it was identified in over half of the samples and in most cases was the only compound detected. These samples were also analysed using an established screening method with QTOF. Good agreement was shown between the two analyses. Discrepancies were likely due to differences in analytical sensitivity and differences in library content. I have a couple of examples of these on the next slides. For this sample, cocaine was detected on the Radian ASAP. Screening using the QTOF did detect further substances, as you can see. These substances are either not contained in the Radian seized drug library, or they were at too low levels for the instrument to detect. For this sample, caffeine was detected on the Radian ASAP. However, more illicit substances were detected with QTOF screening. This is likely due to low levels, as MDMA was detected by the Radian, however this was below the 850 cutoff. And also the library content, as methoxetamine and 4-methyl-F-cathinone are not currently in the Radian reference library. As I mentioned earlier, we have recently added xylazine to the LiveID seized drug reference library following the emergence of this compound as an adulterant. Criminal drug networks are mass-producing fake pills which contain fentanyl and are marketing them as legitimate prescription pills to deceive unsuspecting customers. These fake prescription pills are easily accessible and are often sold through social media and e-commerce platforms, therefore making them available to anyone who owns a smartphone. Many of these fake pills are made to look like prescription pills such as oxycodone. A real counterfeit M30 pill extract was provided to Waters for seized drug screening and confirmatory analysis by the San Diego County Sheriff's Department Controlled Substance Unit. The pill extract consisted of 1 mg of a pill dissolved in 1 ml of ethanol and subsequently further diluted in 20% aqueous methanol. On this slide are the LiveID results for the Radian ASAP analysis of the M30 pill extract. As you can see, fentanyl, metodesnitazine, caffeine and xylazine were all detected with match scores greater than 800. The comparison spectra for fentanyl and xylazine are also shown, with the acquired spectra shown here in yellow and the library reference spectra shown here in blue. So to summarize, from this presentation, you will see that ASAP-MS is an easy-to-use, rapid, and accurate screening technique that provides MS data directly. This technique has shown promise as a simple screen for seized drug samples. Preparation of samples is quick and simple, and ASAP-MS analysis and spectral library matching takes less than 2 minutes for each sample. I would like to take this opportunity to thank Dr. Michelle Wood for her continued support during these projects. Also, Jeff Salamat and Alexandra Harvey from San Diego County Sheriff's Department Crime Laboratory for supplying the M30 pill extract, and my colleague Mike Wakefield for assisting with the collection of data. Application briefs and further information relating to the topics and procedures discussed can be found at the links on this slide. Thank you for taking the time to attend this presentation, and if you have any questions, please feel free to ask now or contact me by email.